the universe has acquired knowledge of itself in the sense that we have knowledge of the universe. But I took it, I think, a step beyond that, in that not only do we have knowledge of the universe in our tiny little role in it, but we have knowledge now of how the process by which we obtain that knowledge.
Yeah. Hi, everyone. Today I'm joined by Gary Cziko. Gary's a professor emeritus in the Department of Educational Psychology at the University of Illinois at Urbana-Champaign, and the author of this book, Without Miracles, Universal Selection Theory, and the Second Darwinian Revolution. This book was recommended to me by a friend, Michael Gusick, and was just excellent. It was people will know who watch this podcast. You know, I love Bobby Azarian's work. I'm really interested in theories of universal Darwinism and knowledge creation at multiple scales and complexity theory. And this book has all of that and more. Reached out to Gary, and he was kind enough to come on the podcast to talk about this book, published, I believe, by MIT Press, 1995, and wanted to just put this on people's radar and dig a little bit into this idea of universal selection theory. So thanks, Gary, for coming on the Metamodern Meaning podcast.
Yeah, well, I'm happy to be here. A little bit surprised. The book is 30 years old, and I've been retired for quite some time and not active in this area, but I took this as an opportunity, your invitation, to reread it. And I can sort of see, I mean, the stuff about Plato and Socrates and all of the early theories of evolution, all that is still relevant. It's just the most, it's not the most up to date I can imagine on the latest developments in combinatorial chemistry and genetic algorithms and all that stuff. But yeah, this is a great opportunity. And reading your work on the evolution of meaning showed me that I try to have a broad perspective, and yours is even like this. And so it's nice to have a broad perspective on a broad perspective. So I enjoyed that as well.
Well, thanks. Yeah, no, and I think that they go together very, very well, and maybe we can dig into some of those connections. But why don't we start off and give people a sense of what this idea is that this book is about? Universal selection theory. Can you give a sense of what does that mean?
Yeah, well, it's basically, this goes back to Don Campbell, the social psychologist who was mostly at Northwestern University and then moved to Lehigh University. But he has this notion of puzzles of fit. And you see puzzles of fit all over the place. I mean, one example is Paley's clock and a watchmaker, right? You stumble across a watch in the field and you say, wow, this is amazing. Somebody must have made this. All the parts fit together and it tells time or whatever. So there must have been a watchmaker. So you see this all over, certainly in the form of biological structures, which is sort of where I'm coming from. So even in the shape of a wing, the wing knows, in a sense, something about aerodynamics and Bernoulli's principle and all these types of things. And, chemistry, and of course, your internal body knows all kinds of things about chemistry and genetics. It's just, where does this come from? So the idea is that we want to explain these puzzles of fit, which are, in a broad sense, biological structures, cognitive knowledge, being able to invent things, technology, drugs, the whole bit, puzzles of fit. So how does this happen? So if you look at attempts to explain these puzzles of fit, there tends to be a trend from what I call providential, then moving to instructional, and then selection, okay? So providential means, just providence, it was provided by a watchmaker, and in the cosmic watch would be God, right? Some providential source, some supernatural source of this. And up until Darwin, that was really the only reasonable explanation for life. I mean, there was really nothing else because we simply couldn't be explained. But then other theories came along, and Lamarck's theories of evolution is an example where somehow organisms that do get created, they somehow learn from their environment, and then they pass this on in the form of some type of genetic instruction to their offspring. And that sort of made sense. And Darwin never fully refuted that either, but he said it wasn't enough. But this is the notion of instruction. Somehow, some system can somehow instruct another and make it adapt. In the sense of biological evolution, it really didn't work because of the separation between what we call the somatic and germ cells. There's just no way that you're working out and getting muscles is going to pass those muscles on to your offspring. It just doesn't work that way. And Darwin then came up with, a selectionist theory that is completely blind process. And reading Dawkins back in the 1970s, The Blind Watchmaker, uh, got me going on this. And I said, yeah, that really makes sense. This is a way of understanding puzzles of fit that don't require the knowledge existing beforehand, right? And so that's one of the basic themes. And if you look in all, even in philosophy and psychology and education, evolution of technology, is the notion that there is selection going on in some way. And there can be in creative thought and science, you have variations of cognitive ideas and a selection of those. And this scientific method, according to Popper, is just Darwinian evolution in the forms of what he calls conjectures and refutations. And so it fits very nicely into all areas where you're interested in puzzles of fit, wherever those might be. And then the
Mhm.
application is people are interested in puzzles of fit. They're interested in how can I better market my product, right? How can I be a better teacher? How can we come up better medical treatments? How can we have better chips and computer programs? All of those things at some point will require, if you don't know the answer, you're going to have to take a stab at it. You're going to have to try something and then be willing to throw it out if it doesn't work, which religions don't typically do, right? But science does, and that's the only things that really progress. So that's where puzzles of fit come from, and universal selection theory tries to, you know, use that as a way for us to make sense of the out of the world and how the primarily living organisms is what I'm interested in, and the products of living organisms
Sure.
certainly as well.
Yeah. Well, no, so that's a lot, and that's really helpful. That's a great summary, and I'll try to say that back a little bit and hit on some of the key points, and let me know if this is basically right. But it seems to me what you're getting at here is these puzzles of fit, right? It's sort of like, wow, I look at this frog and it's perfectly camouflaged in its environment. Or yeah, you mentioned the bird's wing, and it's perfectly sort of designed to do something, right? And so there's this question of design that, as you noted, there have been different attempts or methods to try to account for. And one is this providential account of, well, it was just made that way by, a watchmaker, by an intelligent designer, this sort of a thing, or that maybe somehow it learned this in its existence, and passed it on over the course of sort of history, which you'd call the kind of instructional approach, or that it's sort of variation and selective retention over time, and that
Yeah.
you get this sort of selection process where there's a filtration mechanism where basically, as Darwin obviously famously noted, that things evolve by means of having a great deal of variation and then a subset of that being selected for against the filtration mechanism of the environment. And as that unfolds and iterates on itself, you get increasingly well coupled fit between,
Right.
say, agent and arena. And so I think what's really fascinating about your book, and this way of thinking, and you're drawing on multiple thinkers in all of this, is that this gives us a kind of meta theory for looking at these fit relationships across different scales. And so you've mentioned biology, you've mentioned living organisms and environments, but there are other instances, right? You mentioned our technology, you mentioned how we create things and try to solve problems, you mentioned scientific theories, and then in this book you really go through the different kind of, in a sense, let's say scales of nature, zooming in at different points, whether it's living organisms, whether it's the neuronal learning that animals engage in, and then you also again just mentioned scientific theories and how in Popper's idea these get falsified and therefore get updated. So it's this grand theory for accounting for the adapted and adaptive complexity that we see all over the place that
Mhm.
really only selectionist accounts are adequately able to describe. That's my attempt to kind of
Yeah.
summarize. How does that sound?
Yeah, if you want to explain these things without miracles, which is the title of the book, I don't see how you're going to get away from selectionism as the way of doing it. I would just add to that, you said perfectly adapted.
Mm,
Perfectly, not necessarily good
right.
enough
Yeah.
and
Right.
better than what was there. We're looking through all these stupid connections on our retina. All the nerve connections are on the wrong side, but that's just how it worked out. We got to put up with that.
Right. Right.
So, and it's these kludges, as some people say, are also support the notion that it was not an all-knowing being that created this, because there's all quirks of the system, that shows,
Right.
once you evolve one thing, you sort of committed to that road and you need to go down that one again, continue it. So that's the only real thing I would add to that. But there's another theme there too, if I could take this, is
Yeah.
that I make a distinction between organism selection in the
Hmm.
biological evolution sense. So, air pollution is increasing in its place in England, and the white bark of the birches is getting darker, and those darker colored moths now are surviving because they're better camouflaged. So that's
Hmm.
selection of organisms or between organisms, and the one that survived, they'll get eaten, reproduce. You can actually see them getting darker. But there's also then evolution through between organism selection discovers, if you will, within organism selection. So one example is the immune system. And that was one of the theories, was that the immune system has to come up with all these novel antibodies all the time because there's all kinds of new antigens, all kinds of new viruses coming in and toxins, whatever. How does it do that? Well, it used to be thought that there's like a template of all possible ones. It doesn't work. And basically what happens is there's a selection process going on there. And this is, when you get a vaccine, this is what's going on. You're selecting for the antibodies that fit those antigens, and then they start reproducing and mutating, and you get a better medicine. So this is going on within the body. And then people like Jean-Pierre Changeux first talked about neuronal man, that this is going on in the synapse. And you look at an infant who's 1 year old, they got like twice as many synapses as we have. And it's not adding synapses, it's selecting them, taking them away, which gives us the knowledge, which is really, really interesting. Like starting a sculpture from a block of
Yeah.
granite and chipping away at it. So we have discovered this in terms of sort of physical things going on in the body, in terms of synapses, in terms of antibodies. But then at the cognitive level, we generate thoughts and conjectures, and we compare them and we think about them. We can think about the future, what's going to happen tomorrow, what are the things that might mitigate climate change or crude production, whatever. And you think about these things and you try them out. And now we have computers to help us do this as well, where you can run simulations, you can do numerical solutions to problems that you couldn't do before just by cranking it out and finding lots of possible solutions, choosing the best one and going ahead with that. So
Yeah.
it's this within organism selection, and now we're taking it out of organisms and we're putting it in silicon in the sense,
Hmm.
and it's there in as we come up with tools. We have like virtual wind tunnels and stuff. You can design a bridge on the computer and run trucks around it, and you don't have to build the bridge and see it fall down. So
Well,
you
and
can do this.
yeah, and AI it is my understanding that there's a deep similarity to the way that these models have been developed to work in similar modes. It's early versions, for example, of teaching computers to play chess, right? Like first they
Right.
would lose all the time, but then slowly,
Yeah.
the more that they lose, they learn from their losses, and then before long, they're unbeatable and they're better than any human. And it's through a an algorithmic process that seems to be able to apply across these different scales in all these
Right.
different kind of universal contexts, and therefore seems, a really well. Actually, it's an interesting question. Not sure if you use this phrase in your book. I don't remember, but this does seem like a sort of theory of everything, or a toe, as they're called these days. Do you ever think about this
Well,
idea in those terms?
but it's not everything because it's about puzzles of fit. And this is where I guess I have some reservations about applying it to cosmology and the
Mm,
evolution of galaxies. Now I know whatever is stable is going to hang around.
Mm.
And there could be lots of things that ain't stable, are going to be. But that to me sounds somewhat different than a number of different things being tried out, and then something. Maybe it's not. I don't know. But to me, it's where you see these puzzles of fit. This is what it's meant to explain, and it may be broader than that. And maybe I just don't know enough about the Big Bang and how that occurred. I know that we're all stardust, as Carl Sagan said, and so. But I've never really thought too much about applying it at the level. I mean, you talk about a rock as having some way of resisting. I see a rock as really different from a living organism.
Yeah,
So
yeah, yeah.
it doesn't adapt, and it doesn't suck in energy the way that we do. What I found really interesting about your book is you're saying living organisms suck up so much energy.
Yeah.
I mean, I would imagine that there are things in the universe that are sucking up huge amounts of energy. But when you can look at the scale of
Right.
organisms,
Right. The density.
that was
Yeah.
kind of mind blowing
Yeah.
to
Yeah.
see how that works.
Well, and just to jump back for a couple things there. One, yes, there are like these notions. I think Lee Smolin, has talked about this, sort of cosmogenesis through selective processes that is an option, but obviously remains speculative. But maybe to briefly go. I want to zoom in on something for 1 second because I find this idea so interesting. You brought up Carl Sagan, and Carl Sagan also said, apart from the fact that we are stardust or made of star stuff, that we are a way for the cosmos to know itself, which is both sort of a poetic expression, but it's also like profoundly true. I mean, if there is knowing going on, we're experiencing that, and we are experiencing the universe and coming to knowledge about it. And so, as part of an instance of the universe, we are the universe coming to knowledge. And so, one of the ideas that I'm really interested in is relating this universal selection theory, which is simultaneous. What I want to say is what I'm interested in is relating this theory to knowledge production across scales as well, because it's simultaneously accounting for complexification and knowledge production. And you also already mentioned the line about the eagle's wings kind of containing a kind of implicit knowledge of the environment, which I also have earlier picked up from folks like Bobby Azarian and Terence Deacon. But you say this right at the beginning, actually, of the book. I'll just read a couple of lines to give people a taste. One of the most remarkable aspects of the universe in which we find ourselves is that the universe has somehow acquired awareness and knowledge of itself. And you go on, the fish's streamlined shape suggests functional knowledge of the physical properties of water. The design of the eagle's wings reveals a sophisticated knowledge of aerodynamics. Indeed, knowledge itself may be broadly conceived as the fit of some aspect of an organism to some aspect of its environment. And I find that I worked with that idea a lot in my own writing. I find this a very potentially profound idea that hasn't been maybe fully given its full share of appreciation. Because it seems like when you're looking at evolutionary, designs in nature, you're seeing, in a sense, a kind of embodied knowledge, right, that gets somehow distilled in the genotype and then passed down through the memory system of genes. And this is why I call it kind of genetic learning. And to look at evolution as a learning process, I feel like recasts the whole evolutionary story in a different kind of way. I was just curious if you had thoughts about that, thinking about this whole theory in those terms.
Well, I actually mentioned somewhere in the book that, yeah, we've evolved. The universe has acquired knowledge of itself in the sense that we have knowledge of the universe. But I took it, I think, a step beyond that, in that not only do we have knowledge of the universe in our tiny little role in it, but we have knowledge now of how the process by which we obtain that knowledge.
Yeah.
And so I was speculating about, meeting extraterrestrial intelligence. And one of the first questions I would ask, where'd you come from? Who is your father? And you got a fish back there in the line or something like that. And I couldn't imagine that they wouldn't know that. Unless they evolved by some completely different process. I can't imagine that either. So I think that's knowing that the universe has evolved consciousness through this process, and then we can make practical use of that.
Yeah. Yeah.
in all kinds of different areas. In education, which is where I really was working, the notion that that students, children need to just be constructive and try things out and see what works and see what doesn't work and be ready to give up on their theories. And this applies to everybody, as
Yeah.
well. And to the extent that you can try out things, physical things without killing yourself through simulations or thinking about it, or then that's even better because you can go through all kinds of different trials. And I think even some of the AI now, my understanding is that like ChatGPT and some of the later versions or that they're working on will now generate a bunch of different answers
Mm.
to your prompt and
Hmm.
then have a meta level looking at that
Yeah.
and saying,
Yeah.
which of these really seems to fit in terms of whatever values are in there, veracity and kindness or whatever. But you have that selection going on at that level.
Yeah.
So,
Let me. That's such a. I love that thought, and it's really important. I mean, the title of this podcast is "Meta Modern Meaning," and in conversations about meta modernism, there's a lot, as one might imagine, with the term that has meta in it, about this notion of sort of recursive reflection, and it's a really interesting notion that, in a sense, this evolutionary learning algorithm has been unfolding, but never, in a sense, self-reflectively applied in a way before human beings with the capacity to use symbolic information processing and all that to understand it, to then use it and in a sense consciously engage in the process, and
right.
therefore in a sense exponentially increase the output of it. That seems to be like a novel turning point or pivot in the evolutionary process itself, is the not just the emergence of consciousness, but the redoubling of consciousness on the processes that led up to these processes,
Right.
and you get this kind of loop, and then you're able to leverage the insights of the entire process that came before. And I think that so there's something very profound about that leap. I think is seeing this deep thing that we are a part of, and then becoming aware through the learning process, by means of the learning process, about the learning process, something like that,
Yeah.
and the new options that opens up. And the notion that not only that, but we're using that knowledge to now generate artificial intelligence,
Right.
and iteratively learning how, in a sense, our own intelligence and other kind of learning processes work by means of this algorithm, so that now later versions of AI are actually incorporating this recursive meta
Yeah.
level hierarchical process into it.
Yeah.
All that is just sort of dizzyingly, it reminds me of like Gödel, Escher, Bach kind of style, like
Yeah. Yeah.
yes, yeah.
Right. And even at a higher level, remember we have OpenAI, we have Meta, we have Google, there's going to be a selection among those too. And
Right.
then you have the Chinese coming out with deep search, and that seems to be much cheaper. So you're getting selection on top of selection on top of selection. So the emphasis is to go beyond what you already know. It has to be blind.
Right.
And that's it. That doesn't mean it's not constrained
Right.
because you're using the knowledge, whatever field you're in, of where you are now, you want to push it further. So the notion of it being blind variation and selective retention, so many psychologists would say, ain't blind, we're smart, we're intelligent, we're coming up with good guesses. Well, they're still guesses. And to sort of embrace that part of it is really important. And another part of that is that those constraints can be very useful, but they can also be limiting.
Hmm.
So you're probably familiar with the notion of an adaptive landscape where you'd
Hmm.
have sort of local minima and hills, right? You have some hills that are higher than the others, and you're
Hmm.
climbing one, and that may be good, better than what's below it, but you can't get to the higher hill here
Right.
without really scrambling everything and trying a completely new approach, right?
Yeah. Yeah.
So those constraints can be useful. So it's got to be blind. You got to take a chance, and you got to try it.
Well, yeah. So a couple
Mhm.
things there I want to pull out. One is, yeah, that this um, always relies for true advance to occur on some kind of memory system, basically
Yeah.
backstopping the process. Otherwise, you're
Yeah.
always just starting from square one, right? So
Yeah.
there's it seems like in all of this, there's an information processing that's going on,
Yeah.
but it's able to retain the successful gains
Absolutely. Yeah.
and store them and then build off of them, and so that's what in like genetic learning that's the genotype of the successfully adapted organism, that it's retained that information in a sense about its environment in its genotype. That's that memory system. But then you get just the same idea, but in different informational substrates, essentially, right? So, like when we
Yeah.
learn individually, we have a memory system in our brain that's fulfilling the same function, but obviously it's a totally different kind of information
Yeah.
processing going on there. But always that we're we're basing our hypotheses, our variations on what has already worked in the past, and then we're sort of going from there. So it is blind, you would say, always, however much it might be based on the constraints of our memory systems that
Yeah.
have locked in the winds. But from there, you don't necessarily know where to go. So you're going to have to,
That's right.
grope around and find out until you hit on the next thing that you can build off of, something like that, right?
Yeah, that's right. And then again, those constraints may be very useful up to a point, and to make the next quantum leap, you're going to have to think outside the box, as it's called, right? And try something sort of totally different. And we can do that now with modeling and computers in a very quick way. But one of the points I was getting at before I somehow got sidetracked was thinking that the selectionism, well, is this really the only way to explain these adaptive complexity and how it continues and how this works? Is there going to be some other way? And then I'm thinking, well, if there is some other theory that's going to be better, well, we're going to select that. So we're back in selectionism
Yeah.
again. So we
Yeah.
can't get out of the tautology of
Well, that's fun
selectionism.
too. I like the selectionist epistemology again, recursively applied to itself. And I guess the only way out of that would be you'd have to somehow hit on some non-selectionist theory by means of selection. But what does that mean? It's an interesting idea. But yeah, there is also this notion that you're pointing to, which is that sometimes those constraints aren't necessarily optimal and we need to break out of them. They can be limiting factors. And so, it's interesting to look at those kinds of moments in evolutionary history where you get some kinds of, real shifts in different directions. The fish body plan was working for a long, long time, but then
Yeah.
eventually you get, something moving onto the land. And so a whole new thing kind of explodes into this new niche. And, I mean, that's part of the story as well. And it's also, it reminds me on the human level, at sort of the cultural level, of kind of Thomas Kuhn's notions of paradigm shifts, right? That
Yes.
like you can work within a paradigm for a long time, but eventually you might bump up against its inherent limitations. And then sometimes the only way out of that is to basically reconstruct and reconfigure the whole thing. And again, that's sort of, there are these sort of design algorithmic aspects to how this process unfolds, but maybe there's a kind of broader meta level aspect of like the templates that this dynamic or this
Hmm.
algorithm works in as well. So it's sort of like there's like the normal science that Kuhn would talk about where you're doing this selective retention and variation, but
Yeah.
then there's also revolutionary science, which is sort of like a meta level version of this happening at a different scale of paradigms themselves, something like that.
Yeah. Yeah. Something like that. But I mean, actually, if you look in biology, one of the advantages of sexual selection is that you're using combinations of genes that work, but in slightly different combinations from the male and the female. And genetic algorithms do that also. Again, I haven't looked at computer science from this perspective in quite some time, but that certainly helps. But then when you want to really shake things up, you throw in some mutations, and they do this, or they did it in genetic algorithms. And most mutations are deleterious. I mean,
Yeah.
they are not going to work. But if you have enough of them going on and something works out okay, then you go along in that direction. And so the combination of the sexual selection using building blocks, but just new combinations of building blocks is one way. But then sometimes you just got to sort of shake that up and take a chance and to see. But I like applying these things, and I'm wondering if people who are working in computer science and engineering and education and developing drugs, if having this kind of overview would actually help them. They're doing all this stuff anyway,
Hmm.
whether they know it or not in some
Yeah.
ways. But does it help to make it sort of a bit more explicit to say, hey, yeah, we need a source of variation. We need to combine things, change things in sort of interesting ways within constraints and then to go outside of constraints. And then we need to sort of speed that up if we can, make a lot of these and look at our selection criteria and ways of retaining that. Can we really bump things up
Hmm.
by using this as a framework? I don't know. I mean, technology is so impressive in what it's doing already. Maybe it's not needed. It's just there and it will be there. But and it helps me and you because we like the big picture on
Yeah.
this type of
Well, I
stuff.
mean, it seems like it would be incredibly valuable again at all these different scales, but I agree. I mean, we do this intuitively, whether we realize it or not. And even, again, some of these advanced AIs with like the protein folding things that are being explored, it's this vast computation that's able to, do all of this variation and see what works in a way that is so, far outstrips the human brain. But it's the same basic idea. And I think again, a lot of those algorithms have hit on the same learning meta algorithm that we're talking about. So I think, yeah, we're using tools that are already doing this and we do it intuitively. But having this as a kind of meta theory that is actually informing our design process and our thinking process and our learning process, I think would be huge. I mean, for me, a big thing also is like I'm interested in the big picture. This is again called meta modern meaning. And so notions of meaning and significance and how we understand our place in the world, these are this algorithm that we're describing, I think, really reaches into the fabric of reality in some significant way. And I think that that's really meaningful and important for people to have a grasp on too. But maybe we can come back to that in a little bit. I did want to ask you though as well, because you are a professor emeritus in the Department of Educational Psychology, and I find
Yeah.
that really interesting. And so I'd be curious just to hear a little bit about how your personal story, like where you're coming from, your background, your profession led you into this line of inquiry. Because in many ways, this book is a mixture of meta theory, but it's got biology, it's got a lot of stuff in there. It's an interdisciplinary work. And yet your background is in education, which again isn't surprising in the sense that we're talking about a learning algorithm here. But
Yeah.
yeah, talk a little bit about how you came to write this book and what that journey was.
Yeah, well, I did my PhD in psychology at McGill University in Montreal, and we were looking at bilingual education there, French, English. And so I was always interested in language acquisition, first and second language acquisition. And so when I went to University of Illinois, I continued that interest, and I was also in a bilingual uh, program there. We were training teachers to be Spanish English teachers, and I was keeping up with sort of the latest in linguistics and cognitive science. And of course, Noam Chomsky was the big name then,
Mm.
and made some startling insights. Some people say he sort of began cognitive science because he comes up with this generative grammar, right? That what we know about language are a set of sort of abstract rules which allows us to generate new stuff. So his famous sentence is what is it? Colorless green ideas sleep furiously, something like that.
Uh-huh.
And you can generate that, and though it's syntactic, but it doesn't can't mean anything at all. And so he says that this is really complex stuff, and kids can't learn it in their lifetimes. They have to have this innate knowledge of how language is, because he would say there's a poverty of the stimulus. So the stimulus is not enough to give them the information they need to generate language, therefore must be innate. Okay, end of story. It's innate. So I'm saying, well, where did it come from then if it's innate? What is the process by which this knowledge that kids have coming out of the womb already have so they can learn language? Where did that come from? Well, that had to be a selectionist perspective. And it's about that time that I came into, I saw Richard Dawkins' book with The Blind Watchmaker. And he's going through all his biomorphs and how we could generate all these things. And I was just saying, this is amazing. This explains how biological evolution takes place. And then he sort of later on developed that further with the idea of cultural evolution and
Hmm.
means. But I said, okay, so that's selection happening between organisms. Well, if this was powerful enough to generate this innate knowledge through a process of line variation, selective retention, why couldn't it be done in the head as well? So it just sort of
Mm,
destroyed that whole notion of of it having to be innate. That doesn't explain it. That's a providentialist explanation in
mm,
a sense. And then so I was really intrigued by that. And then I read into Don Campbell's 1960 paper with blind variation, selective retention. It was in Psychological Review as method for understanding creativity and other types of cognition. And I read that, and he, unlike Dawkins, I was applying it to cognitive processes,
mm.
creativity, real stuff that I'm interested in as an educator. And I read, and I thought I came up with this idea myself that this could be used in the psychological sense within organism variation elections. And he had it all laid out there. And this was like 20 years before
Convergent
I came up with it.
evolution, one could say.
Yeah, yeah. So it's funny. He was at Lehigh University then. I just called him up and said, "Hey, Professor Campbell, I found your paper and I had these similar ideas." We talked for like an hour and a half on the phone out of nowhere. And he says, "Come and visit me." I went to visit him a month or so later. I was in Illinois. He was in Pennsylvania, not too far. And we talked and talked for like a day about all this stuff. And he showed me his letters from Popper that he had
Mm,
corresponded with. And I felt this link back to
mm,
the origins of this idea. And of course, Popper was using it for scientific theory, right? And how
mhm, mhm.
science advances. And so I said, "Wow, I'd like to write a book about this." And he said, "Do you have tenure?" I said, "Yeah, I just got tenure. I'm a social professional." I said, "Go for it, write the book." And that's how this thing came about is through these things happening. And yeah, so it was like 5 years working on that. And he said, "Where should I be published?" And he says, "Go for the best. Go for MIT Press, the Brantford book in print." And I said,
Hmm.
"Okay." And boy, they put you through a review process, and they invite people to review this. So I'm criticizing in the book, and it didn't always work out so well, but it got through. So that's sort of where it came from. And yeah, it's uh, sort of much bigger picture than just working on educational programs, but I find it really practical stuff, and I use it all the time. I have
Yeah.
grandkids, and I'm saying, try another idea or try this out. Don't be afraid to be wrong. You got to be wrong if you want to get anywhere.
Yeah.
And coming up with new ideas. How can you do that? Being exposed to new cultures and new foods and ideas
Mm.
from other places is just so enriching, and
Yeah.
it's really important.
Well, oh gosh, I think so much it comes out there. Just on that last point, though, just real quick, yeah, I feel like a lot of people intuitively understand or have a sense for, or maybe just, I don't know, programmatically assert because it's expected of people to, but that diversity is really important, right? But not everyone can give an account for exactly why and some of the deeper reasons behind all that. But if you're lacking in relationship to more parts of the world and other perspectives and other cultures and ethnicities and all this, then you're lacking in all of this depth of experience and knowledge about reality, which is really
Yeah.
really important, not just in the sense intrinsically but also for discovery, for innovation, for insight, for greater self-knowledge, all these things. It's like the richness of variation,
Right.
within the context of human experience is also all of that. But also wanted to mention something that you do really well in the book, because you were just giving a lovely little sort of lineage of this kind of intellectual tradition, from you to Campbell back to Popper. But in the book, you also talk about a number of other people who've used some form of this. And I think, was it Donald Campbell who came up with the whole bibliography of sources, or it could have been, maybe it was you. There's a
Yeah, We did that together. Yeah,
Yeah,
we did that
yeah.
together. The evolutionary epistemology bibliography.
Which
Yeah,
is just this like wonderful trove of instances from thinkers in the past, from William James to Baldwin to going back to different philosophers and thinkers using this or intimating this basic insight, which doesn't really get formalized, I guess, until maybe Campbell himself or maybe Popper for the
yeah,
first time to kind of officially say this. But people had intuited some form of this, and as an intellectual kind of lineage, it has quite a pedigree in that sense. And there's some stuff in there that I thought was really cool, and I'm really excited to check out that bibliography because again, it feels like an untapped mine of insight that would be again just like really revelatory. I think in for all these different reasons that we're talking about. So I just wanted to make that point as well.
yeah.
Yeah, no, go ahead. I didn't want to cut you off though either,
But
but
then, but
yeah.
then that, but what I'm also impressed with is when you look at all these different areas, whether it be philosophy or biology or technology or education, you get this providence to instruction to selection. I mean, and I have quotes all over the book to show how this is sort of working in that way. Now, if there's going to be something after selection, I'd like to know what that is, but that's the thing I have a hard time trying to understand. One of the things that I wanted to ask you was you're interested in the evolution of meaning,
Mm,
and I do have a chapter in there, which is sort of a brief review of perceptual control theory, which was developed by William T. Powers, who I also had a lot of interaction with. And the notion is that our behavior is a way of controlling our perception, not
mm,
the other way around. And this goes back to, and then 1995, I wrote another book, also MIT Press, The Things We Do, using the insights of Bernard and Darwin to understand the what, how, and why of our behavior. And the notion of stability, Bernard talks about the milieu interne, the organisms have to keep things controlled inside their bodies.
mm,
And that takes energy, right? These are
mm,
dissipative structures. But to be able to do that, it's an internal control system, and behavior is sort of an external control system. And evolution has told us, in a sense, what are the types of things that organisms need to control, both inside, which sort of
hmm.
happens automatically, but also in terms of food and staying away from danger and being able to find mates. And in your work, you talk about that as being important for meaning. That
Mm,
is meaning
yeah,
in a sense, but you don't talk specifically about the notion of control in that sense,
yeah,
that I want to be able to control the temperature of my body, and my body can do that up to its kind of self, up to a certain extent, but then I have to put clothes on or change my climate and other things, and that's important. And of course, getting food. So this notion of control going from inside to controlling the external environment so that it'll
yeah.
keep me alive and reproducing. I see that as fitting right into what you're talking about for meaning. I mean, you talk
Yeah.
about little bacteria that move toward nutrients and away
Yeah.
from toxins. It's right there.
Yeah,
And
no, I totally agree. I mean, what would I say to that? One is that, yeah, you can use some like cybernetic framing, I think, really well to get at sort of the toy model of what this meaning or goal-directed behavior is really kind of doing. And you talk
right.
about, I believe you have some text in your book about cybernetic systems and temperature control systems and all that. Yeah, and the cruise control on your car and all that. But these are goals that are set, right? And that there's sort of a sensitivity to and then a reaction to, and that creates a kind of normativity, a kind of normative goal state that then can either be successfully reached or not, and then behavior can shift accordingly. And I really love the notion of perception control theory and Powers's work. Unfortunately, when I went to go buy Powers's work, it's I think out of
Yeah.
out of print, or it was like it's one of these academic imprints that it's sort of like $200 to buy the book or something. There was a limitation there because I found his work referenced, I think, by Greg Enriquez in one of his books, and I thought that sounds really interesting. So
Uh-huh.
I think from what I understand about it, it's all the basic same same idea, or at least a very similar idea, which is this modification of behavior to reach desired goal states. And that when you set this within sort of a adaptive complexification process, you're going to get more complex goals and you're going to get more complex, behavioral responses and these meta levels of reflection and, learning processes that
Yeah.
are going to be recursively, looping back on themselves. And that is to the point where you get to human beings and the meanings that we have. It's at that level, but you can trace that evolutionary, tree back in time, as it were, and see simpler versions of this play
Right.
out. Whether it's way back towards bacteria, or whether it's more mid level with other kinds of animal behaviors and this sort of a thing. But anyway, so yeah, so some of the nuances I might be missing, but the general thinking there, I think, is exactly it. And I think that I see all of this as sort of one cohesive meta
Mhm.
theoretical or arch theoretical framework, which is something like this grand story of evolution beginning from really simplistic rudiments, but moving by means of this sort of evolutionary learning algorithm to increasingly find adaptive complexity that iteratively builds on itself over and over and over again. And as we see
Yeah.
that happen, we find this evolution of meaningful information building up on itself. That's the story I'm trying to tell with my work. But
Hmm.
it's why I was interested in your book and wanted to talk to you, because I think that you really describe what that algorithm is really, really well, and you give all these instances of it, and you give a sense of this is happening at all these different scales.
Yeah.
So yeah, so I think there's deep similarity there. But I would love to dig more into Powers' work and that theory specifically. And
Uh,
yeah,
have you looked at the Internet Archive? You could probably get a copy there.
that's a good
Uh,
idea. I tend to hate reading things on a screen. Even I don't even have like a
okay.
Kindle or anything, but I will. I
Oh,
will.
really?
Yeah,
Yeah.
I prefer, I prefer the printed
Yeah.
word. Uh,
Yeah. Well, I think even,
especially because I tend to feverishly highlight
oh, I
in all of
know.
my books
Yeah.
and underline. So
Yeah.
I deface the books that I write so that we can have these kinds
Well,
of in-depth
I
conversations.
got a copy of your thing here in Zotero, and I've been highlighting all kinds of stuff for different colors. Green for things I really like, a yellow, neutral, and red I don't like so much. And
I'd love
so
to. I'd love to go through my own error correction process with you sometime. So send me what you don't like, and
oh,
I'd
it's
love to.
just,
Yeah,
yeah, yeah, no, most of it is fine. There's some things I really don't understand, but but not to get too much into that.
yeah.
This is still. I don't know if it's in print at MIT Press, but if you go on Amazon, there are lots of second copies that you can
Oh
get.
yeah, yeah,
I just got one for like $6 and it was in great condition, so I was happy to see that. And you can also borrow it on the Internet Archive. That may not last too long because they're being the
right.
subject of suits by publishers for
Yeah.
copyright infringement. So there's that. But you might be able to find the Powers book
Well, yeah, no, and I
that
will.
way.
I'll look into that. And I do recommend people get a copy,
Yeah,
certainly, of your book. So please go check it
yeah.
out. It is affordable, and you can purchase it. But before we start to wrap this up, there are a couple more questions I'd love to just run by you. One is you do talk a little bit about sort of the cognitive developmental psychology tradition relative to some of this. Uh,
Hmm.
Piaget is in here, but you have a bit of a critique of Piaget. Baldwin is in here, but you actually say Baldwin was kind of hip to all this even back in what it
Yeah.
was 1910. So as someone who is coming out of a Department of Educational Psychology situation, yeah, I'd be curious if you could make any kind of bridges or connections between universal selection theory and the Piagetian tradition or the constructive developmental tradition broadly, as you're familiar with it.
Yeah, well, again, you tend to find in education the providence, instruction, selection trend going on. I mean, if you go back to the Greek philosophers, Aristotle would just, sorry, Socrates would just ask questions, right? Just Socratic questioning, and eventually he would be able to get realization from his student that the area of a square that's 3 by 3 would be 9 and not 6, for example. And he didn't tell him that, but he would just Emily Lee question. And he said,
Right.
well, where did that knowledge come from? Well, it was already in his head. It just had to be pulled out. It was provided by whatever. It's a providential type of thing again. Uh, And then, of course, you have the empiricists, with Locke and others who say, no, everything is based on senses. We just get instructed. All this comes through here. But that doesn't explain a lot of what we already seem to know when we're born in this. And so Piaget talked about knowledge construction, but he really, and he said this is important, but he didn't really use selectionism as a real-time constructive process. So he would say that there are these stages that you would go through, almost providential in a sense, right? So you'd have concrete operations, formal operations, as children would, sort of decenter themselves and realize that, if you had two balls of clay the same size, and if you roll one out into a log sausage, it isn't more just because you've changed its shape. But he didn't really embrace the notion of the children coming up with different theories and then selecting them out, perhaps with the help of a teacher to come up with the best thing. And then you have a nice example of this constructionism, a selectionist in a sense, is Maria Montessori, where she would create all these kinds of gadgets and games and devices that the children would sort of explore with and see how it worked. And they would come up with theories about that. And they were like little scientists. So you have that going on as well. But it still looks like in education, and it's still a common thing, is, I lectured at the University of Illinois. You stand up there and you expound your knowledge and you instruct. And I tried to make some changes when I was doing that. I used to teach an introductory statistics class. And what I would do is to put the students into like groups of 5 and then give them problems to work on. And they would huddle around the computer and try to figure things out. And there would be some that were better than others, but they would be turned into Socrates and asking questions. And they would actually construct that knowledge right
Yeah.
there in a constructive way. And that has had some effect, certainly on education as well. But there seems to be some resistance still about the notion of blind variation
Mm,
and letting it rip, in a sense, letting students come up with
yeah.
their ideas themselves and then filtering those out and
Yeah.
being and the importance of being wrong. Because if you're not going to be wrong, there's no way you're going to increase your knowledge about anything.
Sure.
So
Yeah, no, I think that's all right. I mean, the one place where, I felt the more kind of red underline for like, was the Piaget, because, well, one, I think Piaget, you can read him in different ways. People have
yeah,
the way he wrote left different ways of interpreting, and he wrote so much, and most of it's in French, etc. There's a lot of caveats there. So what exactly he might have said even in one place versus another, and what he would have ultimately said.
yeah,
There's all that, but the way I read Piaget is this selectivist process, in the sense that he talks about equilibration and accommodation, or I'm sorry, assimilation and accommodation,
yeah.
right? And so I see something very similar there. And here he is drawing directly on Baldwin, who you do favorably quote. I'll just read this because I thought this was great. This is from James Mark Baldwin, kind of a huge influence on Piaget, wrote, and how far the method of law called by Darwin natural selection goes, what its range really is, we are now beginning to see in its varied applications in the sciences of life and mind. It seems to be, unless future investigations set positive limits to its application, a universal principle. For the intelligence itself, in its procedure of tentative experimentation, or trial and error, appears to operate in accordance with it. So Baldwin already was hip to the idea that there's some kind of Darwinian process to this, and he had the notion of habit and accommodation, which I think seems
Mhm.
very similar to kind of the memory system that we were talking about earlier. And then
Yeah,
accommodation is basically, what you have to accommodate to and fitting into that. And Piaget picks that up as well and talks about assimilation and accommodation. So anyway, I'm just saying, I think there's a way of reading Piaget that where you can see him hitting on this dynamic too, by
yeah,
saying that, basically we vary our behavior. We have to accommodate to what is, but when we find something that works, then we kind of get a
yeah.
certain kind of, schema, and then we accommodate things to that. Or I'm sorry, we
Hmm.
assimilate things to that. And if that doesn't work, then we have to mess
Yeah,
around
yeah,
and
yeah.
find out again. And this is this recursive complexification process. That's how I read Piaget anyway. And I think that there's a way of understanding that potentially that can sync that up. At least
Yeah,
I'd want to try to do. I'm trying to do that in my next book, actually, in the sequel to the one you would have read.
yeah.
So I don't know.
Uh,
Any thoughts on that?
Yeah, I have to look at the sources again for Piaget. I actually spent a sabbatical year at the University of Geneva
Oh, cool.
in 2007, no, 1990s, 87, 88, I think, a long time ago. And so I thought that was spent an interesting year there. But
Mm,
I don't think Piaget would call himself Darwinian or selectionist
mm,
in any way. And I remember discussing that there with some of the faculty
mm.
who knew him and
Yeah.
worked with him. And I think part of that would have been a reaction against Skinner's behaviorism, where he's
Mm,
looking at this, and Skinner was Darwinist or selection, but he's selecting specific
yeah.
behaviors
Yeah.
and not recognizing that the behaviors vary in order to get the goals
Yeah.
similar. And he's throwing out any cognition, which just doesn't work because you need that for goals. So I think there might have been some of that branding that was not popular at the time among cognitive scientists, as opposed to Baldwin, who seemed to embrace it.
And there
So
is this kind of Kantian flavor to Piaget where it's sort of like, these categories have a kind of a priori element to them, some would say. And so,
yeah,
yeah, these stages, as you suggest, are somehow, yeah. Anyway, people debate exactly like the metaphysics, the ontology that he has, or yeah. And so there is a way of reading him being more in kind of that Kantian tradition of thinking about that. So,
yeah,
and where, Kant would have that kind of instructionist take on things. Oh, well, no, I guess it'd be providentialist because it's sort of like we
yeah,
have these innate categories, right? And
yeah,
so we use those and yeah, so he's kind of in that. So I mean, again, all the problems with epistemology that people have debated, and by extension, sort of debates around ontology and metaphysics, they all seem to bump up against these issues that selectionist accounts for learning do a lot to help resolve.
yeah.
But before we go, we got a few more minutes. I just wanted to throw you a few popcorn questions here. One is, you've been talking about well, we brought up earlier kind of the lineage here and other ways that people have talked about this in the past. I'd be curious, to the degree you might be familiar at all with Hegel and dialectics, whether you see those ideas as relating to this selectionist account of knowledge.
Not really. I haven't run into. I mean, I certainly had some encounters with Hegel, but I am not uh, uh, qualified to make that connection. I mean, I was looking for things that were clearly sort of providence, instruction, selection, and Hegel. I just can't tell you anything
Yeah.
about in relation to this. Haven't thought about it that way. I
Yeah. I mean,
haven't been directed to him.
I'd be interested in there's something dialectical in the notion of evolution's progression through this learning algorithm in the sense that when we hit what he would call contradictions, right? Or what in Hegelian thought is sort of like these tensions, these contradictions, then that synthesis is sort of that like that fit that gets found between these sort of
Yeah,
polarities. And I'm interested in the way that you can apply dialectical thought to this sort of thing. So, but yeah,
yeah,
that was one question. And the other question is a bit more metaphysical, I guess, which is, this book is called Without Miracles. But there's another way, again, maybe this is poetic, maybe it's a semantic slippage, but in a Carl Sagan-esque kind of way, at least, it does seem like this whole process is rather miraculous, right? It's sort of like if this is like real miracle stuff. Like,
yeah.
I was curious if you had any thoughts about that. It's sort of the grand scope of things.
Well, I mean, all the steps are gradual and cumulative, and there's really no magic going on anywhere. But yeah, when you look at the whole thing, it's awesome. I mean, and I think that's this meta modern view of spiritualism is that you just find this connection, and we do have this connection to the universe. Uh, You're talking about, I guess, spiritualism without spirits, in a sense.
Yeah,
Uh,
I mean, here it's sort
yeah,
of it's exactly that, sort of the miraculous nature of existence without the sense of miracles in some kind of breaking the laws of
yeah,
nature kind of way, right? It's
yeah.
sort of it's miraculous in the more colloquial sense of like, wow, awe-inspiring, this is incredible, not we're mystified and we have no idea how
Yeah.
this works and it's all magic. But I think that it's still miraculous in that other
And
sense.
also an appreciation of where we are in terms of the evolutionary scale,
Mm.
what we know, what we understand, the type of life that we can live, having technology and all the food in most places of the world that you would ever want. And yeah, it's just amazing. Of course, that comes along with some nasty stuff,
Mm.
knowledge that we're going to die.
Mm.
And this is nothing, no other species that I know of worries about that.
Yeah.
But we certainly do. And of course, we have all kinds of cultural things and religions to try to account for that and either say, well, it really doesn't happen, or, it does happen, but it is going to happen, at least in the corporal sense. So there's that. So yeah, yeah, I can understand. It is the without miracle though for me doesn't take away the R. It doesn't take
Yeah.
away how incredible this is. But then realizing that we screw up along the way and we're stuck with an appendix that we don't need and backwards retinas, and okay, we'll put up with that. So that's kind of fun. And then we can reflect on ourselves. The other thing is humor, how we can make fun of ourselves.
Mm.
And I don't think any other species has that as well. Well, one thing I wanted to touch on, though,
Yeah.
is this notion of purpose.
Yeah.
And psychologists, well, for the longest time would say, no, there can't be no purpose. How can you have something happening in the future causing what's going on? And, you look at perceptual control theory and, well, no, you have a purpose because you got to support your family. I see traffic out my window going to work or coming back from work.
Hmm.
And there's a whole hierarchy of purposes
Yeah.
that we go through. And now we have built these into machines, right? So, my analogy of the cruise control. Now we have dynamic cruise control. And I would say cruise control in your car has a purpose.
Mm.
I don't have a problem because we have created it to have a sensor, have a comparator, and to vary things so that what is perceived as the speed is the same as what has been set. So we have purposeful systems. Is that something that you can live with? I mean, the notion that machines have purposes?
Well, that's a really great question. I would frame it slightly differently, though, because I think that machines are artifacts that the human mind has generated to have some purpose. I think that the purpose that we see in nature that emerges, that comes, through the evolutionary process up to humans, is an internal experience of being a cruise control operator, if that makes sense, right? Like
Yeah.
the machine has no uh, ultimate normative goal state because it doesn't face, it doesn't have, what would you say, the intrinsic regard for its own existence. I think that when
Hmm.
you get evolutionary processes going, living entities have an intrinsic regard for their own existence, and it's that little tenuous thread that you can trace all the way up to us and our sense of purpose. This is why I also think AI and those kinds of things, while in their own way mimicking, learning processes, also similarly can't have purpose. Because if you don't have skin in the game, if you can't die, then in a sense you can't really have purpose in that sense, in my thought. Now maybe in the same way that I've talked about, rocks having meaning because if they exist and there's some normative goal state, we could talk about, a cruise control system as having purpose at
Yeah.
that level.
Yeah.
So I'm open to that and that sort of thing. I think that if something exists, it has to have some kind of meaning as the way I define it, as sort of information bearing on its viability with causal power. So yes, to everything in that sense having meaning or purpose, but I think that when we intuit the significance of what that's really getting at, it's the goal has to be at root, viability
Hmm.
and the continued existence. And so I think that if we don't have
Yeah.
that in the mix, then we
Yeah.
might have ancillary things that we've created with purpose. Does that make sense? I don't know what would
Yeah.
you
Yeah.
make of
You
that
you
thought?
you you're trying to anchor the purpose into a more existential
Yeah.
perspective. And yeah, that certainly makes sense because uh, purpose and being able to control our internal and external environments is absolutely important for life. And but we can create these things. I mean, if you look at like the Tesla robots putting cars together, it's
Mm,
really amazing. And they're using these feedback control systems all over the place, particularly for things like welding. Uh, you know, the chassis rolls up and then they get information exactly where it is because
yeah.
that has to be calibrated. But there are real-time things going on all just like, they got to get this soldered to this, and they will do what they need to do to
Yeah.
have that done. And so, but yeah,
It
it's imparted in them. It's given to
yeah.
it. And in contrast, there's no way that I can go to my thermostat and change the temperature. I can't get into your brain and make you
Right.
more kind or less kind or
Yeah.
more athletic. This is just something that is built in.
Yeah. And
So
and
that's
actually
different.
this is helpful because I'm actually going to be giving a talk at the Utah conference coming up in next month, and its theme is consciousness, and Michael Levin will be giving the keynote, and it'll be great. So that's also a plug for that if people are watching this. But this is some of the stuff I'm going to be getting into. But one of the things I would observe too is that if humans were taken out of the picture, those Tesla robots would eventually break down under entropy, right? You need that
Yeah.
energy flowing into the system to keep them going. And right now we are doing that
Right.
for them. So I think that my notion of like meaning, at least evolutionary meaning, is something around the intrinsic emergence of you got to take care of that part first, right? Because
Yeah.
that's the root. And so I think that when I talk about meaning, it's something that kind of flowers out of that seed because as you get the stimulus response, behaviors, and then that complexifies into more kind of, unlimited associative learning that you see in animals and then on up to
Hmm.
humans. You get this, it's all built off of this complexifying stack that's building off of itself. And it's all rooted in thermodynamic imperatives to continue
Yeah.
existing. And that is in intrinsic relationship, whereas in like a robot or a cruise control system, yeah, it doesn't have that. And so it does have goal states, but they're extrinsic. And I want to make some kind of significant statement regards to meaning in that terms. But I think the mechanics are still, I mean, they're really important, right? And I think that, well, one of the things that for me is really important about this takeaway, though, is why we can see why certain so-called transhumanist understandings of the future have to not be right, because the notion then that you could knock away the entire complexity stack on which technology is resting,
Yeah.
is sort of, it's missing the whole point that we won't be able to just let it go and then AI will take over everything, because unless it has intrinsic meaning making processes relative to its own existential viability, then well, yeah, that'll never happen. And it also gets at some of the alignment issues. But I don't want to take us, but that's
Yeah.
my thought. Yeah, so that'd be my take on that.
Yeah. Well, interesting. Well, I think we've satisfied some purposes here. And
Yeah, this has been
and,
absolutely wonderful. I really appreciate you taking the time to talk about this. Again, obviously it's clear, but I'll say it again. Check out this book. It's wonderful. I think that this book is I was delighted to find it because, you did mention it was written, I think it was published in 95. So these ideas have been out there, but I'm really excited to see them really gaining traction. This is also my hope, I guess, that they really
uh-huh.
start to inform this new emerging paradigm. As we've also suggested, these ideas or some form of them have been kicking around for, in a sense, ever, but I see them taking on a new sense of significance and urgency, even
Mhm.
as we're dealing with AI and some of these things, this meaning crisis that people don't know what to make of, and like what is
Right.
meaning and what is, we haven't talked about the institutional breakdown aspect, including the institutions of education, but similarly, like what is learning and how should we actually be approaching education, and if we don't have a good theory of learning, there's so much here. And so this is this kind of work is it gets to the heart of an emerging paradigm, which I'm hopeful can really flower and be the source of a lot of positive developments in culture. So thank you
Yeah.
for writing it. Any other final thoughts before we
Well,
bring this to a close?
yeah, I mean, I'm pleased to see your enthusiasm for these ideas and taking it to the next level, if you will, by extending it to these other ideas, which I find really, really fascinating. So, yeah, and also giving me motivation to read the book again.
Yeah.
And I learned something. It's funny to learn stuff from yourself, isn't
Mm,
it? Because I hadn't seen it in quite a while. So, yeah, this has been great. So,
awesome.
thanks so much for having me, and enjoyed talking with you. And
Awesome.
yeah, good luck with all your writing and your conferences and et cetera.
Appreciate it. Well, thank you so much, Gary Cziko. This was a pleasure and an honor. So, yeah, we'll be in touch, and till next time, take care.
Okay, goodbye.